100 years of radio noise has already left Earth, spreading outward like a faint, glowing ripple through the nearby stars. To us, it sounds like curiosity. To something older, hidden, and careful, it might sound like a location. The dark forest solution to the Fermi Paradox asks a deeply uncomfortable question. What if the universe is not silent because it is empty, but because everyone else has learned to stay quiet? If this kind of calm, mysterious science storytelling helps you think, rest, or drift into the night, please leave a like, subscribe for more long-form space documentaries, and share this video with someone who enjoys the stranger edges of the cosmos. Thank you for spending your time here. As you listen, leave a comment with where you are watching from and what time it is in your part of the world. Now, let's step carefully into the silence between the stars. The modern form of the Fermi Paradox begins with a mismatch that is almost too simple to dismiss. The Milky Way is not a small system with a few rare chances for life. It is a vast spiral of stars, gas, dust, and older stellar ruins, carrying somewhere between 100 billion and 400 billion stars across its disk and central bulge. Around many of those stars, planets are now known to be ordinary rather than exceptional. Some are locked close to dim red suns. Some circle in cold outer regions. Some move through temperate zones where liquid water could exist on a rocky surface, at least under the right atmospheric conditions. None of this proves that biology is common. It only removes an older comfort: the idea that planets themselves might be so rare that the question ends before it begins. The galaxy appears to have supplied enough worlds, enough chemistry, and enough time for the silence to become difficult. The first pressure comes from scale, but the second comes from age. The universe is about 13.8 billion years old, and Earth is about 4.5 billion years old. The Sun is not among the first stars, and the solar system is not placed at the beginning of cosmic history. Long before Earth had oceans, long before its crust cooled into stable plates and basins, other stars had already burned for billions of years. Some of them would have hosted planets. Some of those planets may have passed through long eras of relative stability. If life can begin under a broad enough range of conditions, then the galaxy had opportunities before Earth existed. If intelligence can sometimes emerge from life, then intelligence may have had a head start measured not in centuries, but in millions or even billions of years. That is where the quiet becomes harder to interpret. 1,000,000 years is a large span inside human history, but it is a narrow interval in galactic time. A civilization that began only 1,000,000 years earlier than humanity would not merely be slightly ahead. It could be separated from humanity by a gulf of capability, as wide as the gulf between stone tools and radio astronomy. Or perhaps far wider. It might not need to travel faster than light. It might not need miracles, slow probes, generation ships, robotic factories, and patient expansion would be enough. If the civilization survived and chose to spread, even at modest speeds, movement between neighboring stars becomes possible across deep time. Over a few million years, a wave of exploration or colonization could move through much of the galaxy. Over tens of millions of years, it becomes difficult to explain why no lasting sign would remain if many civilizations had taken that path. The expectation is not that every advanced society would build the same machines, or think in the same patterns, or announce itself in radio messages. The expectation is only that energy use leaves consequences. A civilization able to alter planets, mine asteroids, build large habitats, harvest stellar power, or move matter on astronomical scales should create traces that are at least unusual. Waste heat should escape. Starlight should be dimmed or reshaped. Spectra should show chemical patterns that are not easily produced by natural processes. Radio leakage may fade as technologies change. But engineering at large scale is harder to hide if it is widespread and persistent. A crowded galaxy should not look perfectly untouched. It should carry scars, structures, or signals that do not fit the slow habits of ordinary astrophysics. Yet the sky has not offered a clear answer. Radio searches have found no confirmed message from another technological species. Surveys of stars have not revealed an agreed-upon population of artificial megastructures. The most interesting anomalies, when studied more carefully, usually settle back into dust, stellar activity, instrumental limits, or unknown but natural behavior. The cosmic background remains natural. Pulsars are dead, stellar remnants, not beacons. Fast radio bursts are extreme astrophysical events, not recognized greetings. Strange light curves can be compelling for a time. But compelling is not the same as artificial. The universe continues to behave as those stars. Gravity, plasma, chemistry, and time are enough to explain it. That does not solve the paradox. It sharpens it. The absence of evidence is not always evidence of absence. But when the search area is large, the possible timescales are enormous, and the expected consequences should be visible. Absence begins to carry weight. The Fermi Paradox lives inside that weight. It is not a formal contradiction in the mathematical sense. It is a pressure point between reasonable expectations and stubborn observation. On one side stands the ordinary nature of planets, the ancient age of the galaxy, and the speed with which technological change can transform a species. On the other side stands a quiet sky. The simplest question is often phrased as, "Where is everybody?" But the deeper question is more precise. If technological life has appeared many times, if some civilizations survived for long periods, and if even a small fraction expanded or signaled, why does the Milky Way still look so natural from Earth? Many answers try to reduce the tension by removing one of those assumptions. Perhaps life begins only with extraordinary difficulty. Perhaps simple cells are common, but complex life is rare. Perhaps intelligence is not favored by evolution in most environments. Perhaps civilizations tend to destroy themselves before becoming interstellar. Perhaps advanced societies lose interest in expansion, turn inward, or become difficult to detect because their technologies are quieter than expected. Each answer changes the meaning of the silence. Some make the galaxy lonely. Some make it tragic. Some make it merely hard to read. The dark forest solution is different because it does not begin by making life rare. It accepts the more unsettling possibility that life may be present and that intelligence may have appeared many times. It does not need the galaxy to be empty. It needs the galaxy to be cautious. In that version, the silence is not a sign that no one is there. It is a sign that those who are there have learned not to be found. The difference is subtle at first, but it changes the emotional shape of the paradox. A quiet desert and a quiet battlefield can sound the same from a distance. So, can an empty house and a house in which everyone is hiding? Observation alone may not immediately separate these cases, because they all produce silence. The dark forest idea asks whether the silence itself might be an intelligent behavior, repeated across civilizations that have no common language but share one basic condition. They exist in a universe where exposure may be dangerous, and where the safest signal is no signal at all. That thought begins with the same facts used by more hopeful versions of the search. Stars are numerous. Planets are common. Space is large. Time is deep. But instead of treating those facts as a promise of contact, It treats them as the background of a severe strategic problem. If many civilizations exist, then each one must consider what other civilizations might do. If communication is slow, intentions cannot be verified quickly. If technological growth can be sudden, a weak neighbor today may not remain weak. If resources matter over long periods, then expansion can turn distant strangers into future competitors. None of this requires aliens to be evil in any familiar sense. It only requires them to be alive, uncertain, and unwilling to risk extinction on a generous assumption. The silence then becomes less like an accident and more like a pattern selected by survival. Any civilization that broadcasts carelessly may be removed. Any civilization that reveals too much may attract attention from something older, faster, or more afraid. Over vast timescales, the visible population would be shaped by this pressure. The loud would disappear. The quiet would remain. A galaxy filled with cautious observers might look almost identical to a galaxy with no observers at all. This is the first dark turn in the argument, and also the reason it has such force as a thought experiment. It does not ask for monsters. It does not ask for a universal hatred of strangers. It asks whether uncertainty, distance, and survival can be enough to make silence rational. If that answer is yes, then the Fermi Paradox no longer points only toward rarity or extinction. It points toward concealment. The stars would not be mute because no minds have risen beneath them. They would be mute because minds that survive learn to leave the sky undisturbed. From Earth, the difference cannot yet be proven. The telescopes still gather natural light. The radio receivers still sift through static. The searches continue, and the great absence remains open to many explanations. But the darkest solution begins by refusing to treat that absence as simple emptiness. It treats it as a possible screen, a quiet surface behind which the real population of the galaxy may be hidden. The problem is no longer only that humanity has heard nothing. The problem is that, in a universe old enough for others to have learned caution, hearing nothing may be exactly what should be expected. Before the dark forest becomes a forest, it begins as a refusal to imagine aliens too easily. Human thought tends to fill the unknown with familiar shapes. A civilization around another star becomes curious, proud, frightened, generous, imperial, spiritual, or lonely. Not because there is evidence for those qualities, but because human beings have no other intelligence to study from the inside. The mind that evolved under Earth's sky becomes the hidden template for every mind that might ever look up from a different world. That habit is understandable. It is also dangerous, because the Fermi Paradox does not depend on whether distant beings enjoy beauty, recognize friendship, fear death as individuals, or organize themselves into anything resembling nations. Their bodies may not have faces. Their societies may not have families. Their languages may not divide reality into the same categories. Their moral instincts, if they have anything that deserves that name, may have formed under pressures so different from terrestrial history that comparison loses its grip. To guess their psychology is to step into fog and begin drawing maps. The darker argument begins by leaving that fog alone. It does not claim to know what alien beings feel. It does not need them to be cruel, noble, suspicious, or wise in any emotional sense. It asks whether there are rules that sit beneath psychology, rules that apply to any civilization simply because it exists, consumes energy, makes choices, and can be destroyed. This is the role of cosmic sociology, a speculative framework that removes almost everything personal from the problem. It does not ask what aliens want in the rich inward sense. It asks what any durable civilization must preserve in order to remain present in the universe. Once the question is reduced that far, the first rule is severe, but not complicated. A civilization that does not protect its own continuation will eventually vanish. This is not a moral claim. It is a selection effect over short timescales. A society might act recklessly, generously, or irrationally. It might value beauty above safety, knowledge above territory, or sacrifice above endurance. But across immense spans of time, the surviving sample becomes biased. Civilizations that repeatedly ignore existential risk do not remain available for contact. Civilizations that fail to recognize danger are removed by danger. Whether that danger comes from their own technologies, unstable environments, cosmic accidents, or hostile outsiders, the ones left to shape the long future are those that either deliberately or accidentally keep themselves alive. Survival, in this sense, is not presented as an emotion. It is the condition required for every other value to continue. A peaceful civilization must survive in order to be peaceful. A curious civilization must survive in order to investigate. A cooperative civilization must survive in order to cooperate, whatever else a mind may treasure. Extinction ends the possibility of treasuring it. That makes survival the lowest common denominator of intelligence at cosmic scale. The second rule is less immediate, but it turns the first rule into a problem. Civilizations tend to grow, not always in the same way, and not necessarily without pauses, collapses, reforms, or deliberate restraint. But life has a physical tendency to spread into available gradients of energy and matter. A biosphere expands until it meets limits. A technological society learns to draw more power from its environment, convert more material into structure, and protect itself against more forms of loss. Even a civilization that rejects conquest may still need redundancy. It may build habitats beyond its original world to avoid being erased by a single impact, a stellar flare, a climate failure, or an internal catastrophe. It may spread not because it hungers for empire, but because remaining in one place is fragile. Once expansion begins, the meaning of safety changes. A single planet becomes too small a vessel for a long-lived species. A single star becomes a local resource. Neighboring systems become insurance, and then infrastructure, and then part of a widening sphere of activity. The dark forest argument does not require endless greed. It only requires that enough civilizations, over enough time, discover that survival improves when resources and habitats multiply. Against that tendency stands the fixed inventory of the cosmos. Matter may change form. Stars may ignite and die. Dust may gather into planets, and energy may flow across enormous distances. But usable resources are not infinite in any practical sense. A star system can be mined, enclosed, protected, or exhausted. A region of space can be occupied by one expanding civilization in ways that make it less available to another. Even if the universe as a whole is vast beyond ordinary imagination, any given civilization acts within reachable volumes, and those volumes overlap if expansion continues long enough. The conflict does not need to begin with hatred. It can begin with geometry. Two growing spheres eventually meet. At the boundary, each side must decide what the other represents. A neighbor could become a partner, but also a rival. A contaminant, a future threat, or an unpredictable force able to alter the strategic landscape. The resources themselves do not carry moral labels. They become contested because survival gives them consequence. Energy can power defenses. Propulsion computation, industry, and recovery after disaster. Matter can become shielding, habitats, machines, weapons, or archives. To yield too much of it may weaken a civilization not immediately, but later, when some distant crisis arrives. In a short-lived world, generosity can be judged within a human lifetime. In a cosmic setting, a concession made now may echo across ages. This is why the dark forest view turns away from personal intention and towards structural pressure. Even a gentle society may face the same hard arithmetic as a violent one. It must ask whether allowing another civilization to grow freely increases the chance of its own extinction. It must ask whether restraint by one side will be matched by restraint from the other. It must ask whether kindness can be distinguished from weakness by an unknown observer. None of these questions depends on the color of alien blood, the shape of alien cities, or the content of alien art. They arise from the conditions of being a finite, vulnerable, energy-dependent order in a universe where other such orders may exist. That is the unsettling elegance of the idea. It compresses the unimaginable variety of extraterrestrial life into a few strategic constraints. It does not say all minds are the same. It says that any mind responsible for a civilization must answer certain questions before it can afford to express its differences. Those questions are not romantic. Can this civilization be destroyed? Can another civilization destroy it? Can the intentions of that other civilization be trusted? Can future technological change overturn present safety? Can silence reduce danger? The answers may vary, but the existence of the questions is difficult to escape. In this way, cosmic sociology becomes a kind of cold floor beneath all richer possibilities. Above it, cultures may rise in forms no human language can hold. Below it, the floor remains. Survival first, because without survival, nothing else persists. Growth next, because stable survival over deep time often demands more energy, more material, and more places to endure. Finiteness follows, because energy and material cannot be promised to every expanding civilization without limit. From those simple pressures, suspicion begins to appear before any alien has done anything hostile. The universe does not have to be filled with predators in the ordinary sense. It only has to be filled with civilizations that understand they can be prey. This distinction matters because it removes comfort from the idea of benevolence. If another civilization is kind, it may still fear what humanity could become. If humanity is kind, it still cannot prove that kindness across interstellar distance. If both sides are kind, each may still recognize that the other side has reason to worry. The dark forest grows from that recognition. The danger is not that every intelligence is born malicious. The danger is that survival can make harmless intentions irrelevant when the cost of being wrong is total loss. A civilization may look outward with curiosity and still choose concealment. It may value life and still decide that unknown life cannot be trusted with its coordinates. It may regret the necessity and obey it anyway. In human terms, this feels bleak because it reduces moral aspiration to a variable inside a larger calculation. Yet the argument is not trying to describe what ought to be true. It is trying to describe what might remain true after cosmic time has punished every strategy that exposes itself too easily. The galaxy visible from Earth may therefore not represent the average behavior of intelligence. It may represent the behavior of intelligence that has survived long enough to become invisible. This is the first tightening of the dark forest solution. Before weapons, before messages, before the image of silent hunters among the stars, there is a simpler and colder foundation. Alien minds may be unknowable, but vulnerability is not. Alien cultures may be beyond prediction, but extinction has the same final meaning everywhere. Once that is accepted, the silence of the galaxy begins to shift. It no longer has to be explained by assuming that no one is there. It can also be explained by assuming that every lasting civilization has learned the same impersonal lesson. Whatever else it believes, whatever beauty it makes, whatever forms of thought move through its machines or bodies, it must first remain alive. Growth turns the dark forest from a fear of strangers into a problem of space. A civilization does not need to be hungry before it begins to press against its surroundings. It only has to last long enough for safety to become a matter of scale. A young technological species may first think of resources in local terms, as minerals under its crust, fuel in its oceans, sunlight on its surface, an atmosphere held close by gravity. But a species that survives its first fragile centuries eventually notices the narrowness of that arrangement. A single world can be struck, poisoned, overheated, frozen, mismanaged, or altered by its own inhabitants faster than they intended. A single biosphere is a cradle, but it is also a point of failure. To endure, the civilization looks outward, not because it dreams of conquest, but because redundancy becomes caution. The moon becomes a laboratory. Nearby planets become difficult possibilities. Asteroids become reservoirs of metal and ice. The parent star becomes not merely a light in the sky, but the central engine of an expanding system. At this stage, growth can look innocent. It is framed as survival, knowledge, backup, and engineering. The first off-world settlements may be small. The first mines may be defensive investments against scarcity. The first orbital power systems may be built to reduce pressure on a home planet. Yet every successful step changes the civilization's baseline. What was once extraordinary becomes infrastructure. What was once a daring mission becomes ordinary transport. Each new layer of capability creates dependence on still more energy. Maintenance, matériel, and territory. Growth does not always feel like aggression from the inside. Often it feels like prudence. That is part of what makes it dangerous in the dark forest argument, because many civilizations could expand while honestly believing they are doing nothing hostile at all. The physical universe, however, does not judge motives. It only records occupation. A belt of asteroids converted into factories is no longer available in the same way to another arriving species. A swarm of solar collectors around a star changes the light and energy balance of that system. A chain of habitats stretching outward from one origin creates a zone in which another civilization must ask permission, keep distance, compete, or withdraw. None of this requires a first shot. Competition can begin before either side names it. It begins when the same usable matter cannot be fully claimed by both. The difficulty becomes sharper because growth tends to compound. A civilization with more energy can build more machines, support more minds or systems, conduct more research, defend more territory, and reach more distant resources. Those resources then increase its energy base again, even if the pace is uneven, interrupted by disasters or restraint. The direction can become self-reinforcing. The society that spreads gains the means to spread farther. The society that remains small may preserve its ethics, but it may also lose strategic depth over long timescales. The difference between restraint and vulnerability can become difficult to separate. A civilization that occupies only one star system may be morally admirable, but in a galaxy where other powers expand, it is also easier to surround, contain, or erase. A civilization that claims many systems may seem dangerous, but it is also harder to destroy completely. In such an environment, expansion is not merely ambition. It becomes insurance against being reduced to a single target. This is the point where finite space enters the problem. The Milky Way is immense from a human perspective, but it is not infinite. It contains a limited number of stars, a limited quantity of accessible heavy elements, a limited supply of stable planetary environments, and a limited set of paths through which matter and energy can be gathered before distance makes the effort too costly. To any one species, the galaxy may seem inexhaustible at first, but exponential processes have a way of making large containers feel smaller. A colony sends out colonies. Automated probes build copies of themselves. Mining networks turn local abundance into propulsion and replication. A frontier that once seemed impossibly remote becomes the inner edge of a larger system. If more than one civilization follows even a mild version of this path, their expanding regions eventually approach one another. The first contact between them may not happen through a message. It may happen through a boundary, through a missing resource, through a star already altered, through a probe that arrives to find another machine already there. At that boundary, the hope of coexistence becomes a negotiation under uncertainty. One side may believe it needs a system as a defensive buffer. The other may need the same system as a source of fuel, computation, or refuge. Both may be peaceful by temperament. Both may prefer to avoid conflict. Yet neither can ignore the fact that resources occupied by the other are resources no longer under its own control. For short-lived animals, that might sound like greed. For civilizations thinking across geological or stellar time, control may feel like survival. A supply of metals might become the shield that saves future habitats from impact. An outer system fuel source might be the difference between evacuation and extinction after a stellar catastrophe. A quiet star might be the place where archives, children, machines descendants, or biological heirs endure when the original home is gone. Resources are not merely wealth at this scale. They are possible futures. This is why the zero-sum element of the dark forest is so severe. In everyday human life, cooperation can create value that did not previously exist. Trade can make both sides richer. Shared knowledge can benefit all participants. Division of labor can transform scarcity into abundance. The dark forest theory does not deny this. It questions whether such benefits can be trusted across interstellar conditions when the stakes include extinction and when one partner may later become powerful enough to dominate the other. Cooperation requires stable expectations. It requires some confidence that restraint will be reciprocated, that agreements will survive political change, and that the other side will not use shared knowledge to become a greater threat. Across light years, those expectations weaken. Across centuries of message delay, they weaken further. Across technological acceleration, they may collapse. A system that looks mutually beneficial in the present may produce a dangerous imbalance later. The very act of cooperation can reveal locations, weaknesses, methods, biology, and vulnerabilities. Sharing can become exposure. Generosity can become intelligence given to an unknown actor. The fixed nature of matter gives every disclosure a harder edge. Once a civilization knows where another lives and what it needs, it also knows what to deny, capture, or destroy if relations fail. The same map that allows trade can guide an attack. The same scientific exchange that allows understanding can reveal how to penetrate defenses. This does not mean conflict is inevitable in every possible case. It means the risk cannot be made to disappear simply by imagining good intentions. Finite resources ensure that decisions made by one civilization can impose costs on another, even without malice. Expansion by one side changes the future options of all nearby sides. In a galaxy with deep time, even small advantages can accumulate into irreversible dominance. A civilization that acts first can secure star systems before rivals arrive. It can hide, fortify, or seed sensors. It can shape the strategic landscape so thoroughly that later entrants inherit a universe already arranged against them. Under such pressure, waiting can look less like patience and more like surrender. The dark forest solution becomes darkest when it suggests that ethics may not vanish, but may be trapped below survival math. A civilization may understand that another has beauty, memory, and interior life. It may even suspect that cooperation would be better in a gentler universe. But if the usable future is finite, and if the other civilization's growth could eventually close off its own paths to survival, hesitation becomes costly. The problem is not only who controls resources now, it is who will control them after another million years of growth. A neighbor does not have to threaten today in order to change the balance of tomorrow. The quiet sky, in this view, is shaped by civilizations that reach this conclusion early enough to survive it. They learned that to expand visibly is to invite calculation from others, but to remain permanently small is to remain exposed to those who do not. They learned that resource security and concealment must be held together, that a civilization must gather enough to endure without making itself obvious enough to be targeted. This is a narrow path, and perhaps an unstable one. It may explain why the galaxy does not glitter with visible empires. Any empire too bright, too large, or too confident becomes information for every watcher. Any civilization too passive becomes easy to remove or ignore until removal is convenient. Between these failures lies the dark forest strategy: take what is necessary, hide what is possible, and avoid becoming a shape against the night. The Fermi Paradox then changes again. The question is no longer simply why no one has expanded. It becomes why no expansion has been allowed to remain visible. If finite resources make growth necessary, and visibility makes growth dangerous, then the surviving civilizations would be those that learn to occupy the universe without announcing the fact. Their presence would not look like grand beacons or open roads between stars. It would look like absence, because absence is the safest mask that growth can wear. The chain of suspicion begins at the moment detection becomes possible, before any weapon moves and before any message is understood. One civilization notices another, perhaps not through a deliberate greeting, but through a pattern of waste heat, an artificial chemical trace, a narrow beam of radiation, or the altered light of a star. The discovery itself is enough to change the discoverer's future. Until that moment, the other civilization was only a statistical possibility, one more unknown in a wide galaxy. Afterward, it has a location. It may have resources, technology, hidden defenses, ambition, fears, or descendants that will behave differently from its present form. The first civilization now carries knowledge it cannot easily put down. It must decide what that knowledge means, and every possible decision is made under uncertainty. This is where ordinary ideas of contact begin to weaken. On Earth, misunderstanding can sometimes be reduced by proximity. Two groups can meet, observe each other's faces, exchange goods, test promises, notice repeated behavior, and slowly build a history. Trust does not appear from nowhere, but it can grow through many small confirmations. Interstellar contact offers almost none of that. Distance removes the ordinary tools of judgment. A civilization 100 light-years away is not a neighbor in the human sense. A signal sent to it would require a century to arrive, and any answer would require another century to return. Between question and reply, generations can pass. Governments may fall, Values may change. Technologies may transform. The message that returns may be sincere and still be obsolete. It may be peaceful and still not represent the civilization that now exists. Even if the words are clear, the timing makes them fragile. Communication across such distance is not conversation. It is delayed archaeology between living powers. The problem deepens because intention is not a physical property that can be measured like temperature or mass. A civilization can broadcast peace while preparing weapons. It can appear silent while building defenses. It can share knowledge in order to study a target more closely. It can misunderstand a harmless signal as a threat, or treat a defensive act as preparation for attack. The chain of suspicion grows from this inability to verify the inner state of the other side. If civilization A discovers civilization B, it cannot know whether civilization B is benevolent, hostile, indifferent, unstable, fragmented, or simply governed by principles outside human categories. Even if civilization A is peaceful, that does not solve the problem, because civilization B cannot know that civilization A is peaceful. Each side must reason not only about the other's nature, but about the other's reasoning. A may fear B, B may fear A. A may fear that B fears A enough to strike first. B may fear that A understands this fear and will preempt it. The loop can continue without any original hatred. Mutual caution becomes a machine that manufactures danger from uncertainty alone. In this sense, the chain of suspicion is not paranoia in the casual sense. It is a structural problem created by distance, vulnerability, and incomplete information. A civilization responsible for its own survival cannot afford to treat unknown intent as harmless when the cost of error is extinction. If it assumes hostility and is wrong, it may destroy a possible friend or waste resources on needless defense. If it assumes friendship and is wrong, it may cease to exist. The two errors are not symmetrical. One is tragic, the other is final. That imbalance bends rational calculation toward caution, and caution, when carried far enough, begins to resemble aggression. The darker logic does not require either side to enjoy violence. It only requires both sides to recognize that the first decisive strike may be the only strike that matters. When distances are enormous, warning time can be long, but so can preparation time. A relativistic weapon, a hidden probe, a directed energy system, a self-replicating machine, or a subtle attack on a biosphere may not look like an invasion in any familiar form. It may arrive long after the decision that launched it, and it may give the target little chance to negotiate once detected. Because attack and communication both cross space at limited speed, a civilization cannot count on last-minute clarification. By the time a threat is visible, the choice that created it may belong to a past that can no longer be changed. This makes waiting dangerous. It also makes signaling dangerous, because a signal does more than express intention. It reveals presence. A greeting carries coordinates. A repeated transmission confirms persistence. A strong beacon announces that the sender has enough energy to spare and enough confidence, or ignorance, to make itself visible to a friendly listener. That may be an invitation. To a fearful listener, it may be evidence of recklessness. To a predatory listener, it may be a target. The sender cannot choose which kind of listener receives it, nor can the sender know who else is listening beyond the intended recipient. A message meant for one civilization can spread into the wider dark, becoming available to powers older and less forgiving than either participant. In a dark forest, sound does not travel only to the person being called. It travels to every hunter within range. This is why the theory treats diplomacy as far more difficult than human optimism suggests. Human diplomacy is supported by shared biology, shared timescales, overlapping needs, and the possibility of rapid correction. Misunderstandings can still lead to catastrophe, but the participants usually remain close enough to revise, threaten, reassure, or retreat. Across the galaxy, revision is slow. Threats are ambiguous. Reassurance may expose more than it protects. Retreat may not be visible as retreat until long after it matters. The very slowness of light turns each message into an old artifact by the time it is interpreted. A civilization reading it must ask whether the sender has advanced beyond the assumptions contained inside it. A peaceful signal from a young society may become frightening precisely because youth does not last. The sender that sounded harmless centuries ago may now be more capable, more anxious, or more divided. A promise made by ancestors may not bind descendants. A treaty exchanged between stars may arrive already aged beyond trust. The chain of suspicion also becomes harder if civilizations are internally complex. Humanity is not a single mind, and there is no reason to assume other technological species would be simpler. A signal from one faction might not represent all factions. A peaceful government might be replaced by a fearful one. A machine intelligence might interpret risk differently from biological ancestors. A civilization spread across many worlds might contain regions that disagree about whether contact is wise. From the outside, this complexity is almost impossible to evaluate. Even a truly benevolent civilization may be unable to guarantee its own future behavior. And if it cannot guarantee itself, another civilization has even less reason to trust it. The unknown therefore multiplies. The question is not only whether the other side is peaceful now, it is whether it will remain peaceful after new discoveries, new pressures, new leaders, new machines, or new fears. Over cosmic time, that is an enormous promise. Under these conditions, silence becomes attractive because it avoids the first link in the chain. An unknown civilization cannot be judged, targeted, or feared in the same way as a known one. It may still be discovered by accident, but it has not assisted the discovery. Concealment does not create trust, yet it reduces the number of decisions other civilizations must make about it. In a universe governed by suspicion, the safest interaction may be no interaction. The most stable relationship between distant civilizations may be mutual ignorance, not because ignorance is noble, but because knowledge forces choices that cannot be made safely. The Dark Forest solution rests on this grim inversion. Contact, the very thing many searches hope for, may be the event that destroys the protective ambiguity around a world. Before contact, a civilization is a possibility hidden among natural noise. After contact, it is an actor with a position, a history, a growth curve, and an uncertain future. The chain begins to tighten because every side now has something to lose and no reliable way to measure what the other side will do. Even kindness does not break the chain unless it can be proven, and proof across the stars may require exposure too dangerous to offer. The result is a universe where peace may exist privately, inside many civilizations, while never becoming visible between them. Each may contain art, care, memory, and restraint. Each may look outward and hope the galaxy is gentler than the logic suggests. Yet when an unknown signal appears, hope must compete with survival. That competition is unequal, because survival speaks with the authority of everything that would be lost. The chain of suspicion does not prove that the forest is real. It only shows how a quiet galaxy could arise, even if many minds within it are not evil. The silence may not be the silence of emptiness, or even the silence of hatred. It may be the silence produced when every civilization understands that being misunderstood is almost as dangerous as being attacked, and that across the distances between stars, the two may become impossible to tell apart. Technological danger is not measured only by the present. A civilization may look harmless at the moment it is detected, confined to its home world, unable to cross the gulf between stars, still arguing over energy, climate, and the limits of its own machines. From a distance, it may seem like a local phenomenon, a brief brightening on the surface of a planet, not yet a force with galactic consequence. But the dark forest argument does not allow the observer to freeze that civilization in place. It asks what the civilization may become, because the future can arrive unevenly, and on cosmic timescales, even a slow technological rise can be sudden. Earth's own history gives the warning its sharpest form. For most of the time that anatomically modern humans have existed, their tools remained close to the body stone. Bone, fire, fiber, shelter, memory, and speech. The surrounding universe was not reachable. The moon was a light, not a destination. The atom was hidden inside matter. Then the pace changed. Agriculture made larger societies possible. Writing preserved information beyond a single life. Metallurgy, navigation, optics, engines, chemistry, and mathematics built upon one another. The industrial era released stored sunlight from ancient carbon. Within a remarkably small interval, humanity moved from animal power and sail to aircraft, nuclear weapons, orbital satellites, planetary radio, and probes leaving the solar system. Human progress is not guaranteed to continue smoothly. It has never been smooth. Capability can accumulate slowly for a long time and then cross thresholds that alter everything around it. A species may appear technically immature for thousands of years, then become detectable and dangerous within a span that a long-lived civilization might regard as immediate. This is what makes youth unstable as a category. A young civilization is not simply weak. It is a civilization whose growth curve is still uncertain. It may collapse before leaving its planet. It may regulate itself and remain modest. It may turn inward into virtual worlds or low-energy stability. But it may also discover new power sources, self-replicating industry, autonomous weapons, artificial intelligence, fusion propulsion, or methods of moving mass through space with increasing efficiency. To an observer responsible for its own survival, the question is not whether the young civilization can attack now. The question is whether waiting removes the chance to prevent it from becoming able to attack later. That is a harsher question, because time does not need to be long by cosmic standards to be decisive. 1,000 years is deep history for human institutions, but for a civilization that has watched stars move for millions of years, it is a brief delay. A society that cannot reach another star today may launch fast probes tomorrow in galactic terms. A society that cannot threaten a neighboring system today may learn to send machines, pathogens, kinetic projectiles, or information hazards after a few more turns of its scientific spiral. The observer does not have to believe this outcome is certain. It only has to believe the probability is high enough, and the consequence severe enough for inaction to become unacceptable. This is the technological explosion as a strategic fear. It turns a weaker neighbor into a countdown whose endpoint is unknown. The problem is sharpened by the asymmetry between offense and defense across space. A civilization spread over many systems may be hard to destroy completely, but a civilization still concentrated on one planet is fragile. Its oceans, atmosphere, food webs, satellites, and cities form a narrow target compared with the size of interstellar space. A more advanced power might not need an armada. It might need only a method that is cheap relative to its own resources and devastating relative to the target's defenses. The exact method is speculative, and the dark forest argument does not depend on naming one. What matters is the possibility that early action is easier than late action. Destroying a civilization before it spreads may be far simpler than confronting it after it has built colonies. Redundancy, sensors, and retaliatory systems. Delay gives the target time to become resilient. Mercy, restraint, or mere curiosity may therefore create future risk. In human moral terms, that sounds monstrous. In the cold logic of survival, it may be treated as prevention. The observer may not hate the young species, but if its intelligence belongs to an expanding technological process, beauty and confusion do not cancel danger. They make the danger more complex, because a species capable of care may also be capable of weapons, deception, and fear. Intelligence is not a promise of gentleness. It is a multiplier. It can solve hunger, and it can design extinction. It can read starlight, and it can hide its intentions. A distant civilization cannot know which branch of development will dominate in another species, or how quickly. The safest assumption may become the darkest one. Any technological civilization not yet dangerous is dangerous in potential. This potential matters more than present innocence. The same logic also undermines the hope that advanced civilizations would naturally spare primitive ones because they pose no immediate threat. A primitive civilization is only primitive at the time of observation. If it is already producing radio signals, altering its planet, building computers, and studying the physics of space, then it has crossed into a phase where its future may change rapidly. The gap between first detection and interstellar capability may be narrow compared with the age of the galaxy. A patient observer may see no comfort in waiting. If the young society survives its own hazards, it may become harder to manage. If it does not survive, the observer loses nothing by having acted early except the moral cost. And that cost may not weigh equally in a mind shaped by other conditions. The darkest part of the technological time bomb is that it makes innocence nearly impossible to prove. A civilization cannot demonstrate that it will remain harmless forever. It cannot prove that none of its descendants will become aggressive. It cannot guarantee that future machines will share present restraint or that future governments, distributed colonies, engineered minds, or post-biological systems will honor early promises. Even humanity cannot make such guarantees about itself. The species that sends a peaceful message today cannot speak for every form it might take after centuries of discovery and crisis. That uncertainty follows any growing intelligence into the dark. An observer who understands technological acceleration may therefore treat all contact as contact not with a present society, but with an entire branching future. Some branches may be gentle, some may be indifferent, some may be catastrophic. The observer does not know which branch will win. It only knows that allowing the tree to grow increases the number of branches it cannot control. This is why the dark forest is not merely a theory of fear. It is a theory of timing. The most rational moment to remove a future rival is before the rival understands the game. Once it has learned to hide, spread, harden its systems, and build retaliatory capacity, the cost of removal rises. Once it has mapped neighboring stars and seeded machines beyond its birthplace, destruction may no longer be complete. A civilization that waits too long may create the very opponent it hoped to avoid. The logic rewards those who act before certainty arrives. It favors preemption over proof. It punishes hesitation when the unknown may be growing. Over millions of years, if such logic governed even a fraction of advanced civilizations, The visible galaxy would be shaped by early eliminations. Young, loud societies would vanish before leaving grand structures. Emerging signals would be brief. The long-lived would be quiet, concealed, or already powerful enough to avoid easy detection. From Earth, the result would look like a natural sky, not because nothing ever rose, but because anything that rose too visibly was cut down before it could become unmistakable. Technological progress itself becomes an ambiguous light. Every achievement that makes a civilization safer from local dangers may make it more noticeable to distant ones. Every improvement in energy, communication, propulsion, computation, and planetary engineering increases both survival and exposure. A species trying to escape the fragility of its birthplace may advertise that it is becoming harder to kill. The moment it begins to solve its own existential risks, it may become an existential risk in another civilization's model. The tragedy is almost symmetrical. The young civilization expands because it wants to live. The older civilization strikes because it wants to live. Neither motive requires hatred. Both are built from survival. What changes is the scale at which survival is imagined. For the young, survival means reaching beyond one planet. For the old, survival may mean preventing unknown powers from reaching too far. The technological time bomb therefore sits at the center of the darkest Fermi solution. It explains why the weak are not necessarily ignored, why the innocent are not necessarily safe, and why first contact may be dangerous even when no one has fired a weapon. A quiet planet may be tolerated if it remains unnoticed. A noisy young civilization may not. The difference is not present strength, but projected future strength. Under this logic, the galaxy's silence becomes a record of futures that were never allowed to mature. The absence of obvious civilizations may not mean that intelligence rarely begins. It may mean that intelligence becomes most vulnerable at the moment it becomes visible, when it is advanced enough to be noticed, but not yet advanced enough to defend the future it is about to become. A forest at night is useful because it is ordinary. It needs no impossible physics, no galactic empire visible from one edge of the Milky Way to the other, and no alien malice written into the nature of intelligence. It begins with a simpler image. Many living things moving through darkness, each aware that sound travels farther than sight, each aware that a careless step may reveal more than it learns. In the dark forest solution, the galaxy is not empty. It is occupied by civilizations whose most important achievement is not expansion, construction, or communication, but restraint. They have learned to behave as though every revealed position creates a question in another mind, and as though some of those minds may answer the question with force. The forest is dark because distance prevents clear seeing. It is silent because silence has become a survival technology. This is where the earlier pieces of the argument draw together. Survival comes first, because extinction ends all other values. Growth follows, because a civilization that hopes to endure cannot remain forever dependent on one fragile world. Finite resources make growth meaningful, because energy and matter claimed by one civilization cannot always be fully shared with another. Suspicion enters because intentions cannot be verified across the gaps between stars. Technological acceleration makes the suspicion urgent, because a weak civilization may become strong before an older one can afford to revise its judgment. Each element alone is incomplete. Together, they create a strategic environment in which concealment appears safer than openness. The dark forest is not a claim that every civilization wants to hunt. It is a claim that every civilization must consider the possibility that someone else does. In such a setting, even a peaceful actor may hide, not because it rejects contact as a dream, But because contact turns a dream into a risk with irreversible consequences, the metaphor is often described in human terms, with hunters among trees, weapons held close, breath controlled, movement softened to avoid dry leaves. That image is severe, but its power comes from the logic underneath it rather than the violence on the surface. In a dark forest, a shape glimpsed between trunks cannot be safely interpreted. It may be a predator. It may be a frightened traveler. It may be harmless, wounded, young, or lost. But the observer cannot know this quickly enough to make trust safe. Calling out reveals the caller. Approaching reveals movement. Waiting may give the other shape time to aim, flee, signal others, or grow more dangerous. The darkness removes reliable identity, and without identity, moral distinction becomes hard to act upon. The tragedy is not that the hunter cannot imagine innocence. The tragedy is that innocence cannot be proven before danger may become decisive. Translated back into astronomy, the trees are not literal objects, but limits of knowledge. Dust clouds, distance, weak signals, stellar noise, and the speed of light all create a darkness made of delay and uncertainty. A civilization can study spectra, measure heat, follow radio patterns, and infer the presence of technology. But it cannot directly inspect another mind. It cannot know whether silence means peace, whether a message means friendship, or whether apparent weakness conceals future strength. The forest remains dark even when instruments improve, because the essential unknown is not only physical location, it is intention across time. A telescope can locate a planet. It cannot locate trust. A receiver can capture a signal. It cannot capture the future behavior of the society that sent it. In this sense, the dark forest is less a place than a condition. It is what the universe becomes when intelligence is separated by light years and bound by survival. The most unsettling implication is that the safest civilizations may be the least visible. A species that spreads loudly may be discovered early. A species that builds structures bright enough to be seen from far away may advertise its energy reserves and its confidence. A species that sends repeated greetings may distribute its coordinates to listeners it cannot choose. These behaviors may be admirable within a hopeful vision of the cosmos, but within the dark forest, they are failures of camouflage. The survivors would be those that learn to reduce signatures, mask engineering as natural processes, avoid unnecessary broadcasts, and treat every emission as a possible leak. They may still explore. They may still gather energy. They may still build. But they do so with the caution of civilizations that no visibility can be fatal. Their greatest works may therefore be designed not to impress the galaxy, but to disappear into it. This would explain why the sky does not reveal obvious empires. Perhaps empires that wish to remain alive do not look obvious. Perhaps the most advanced societies are not the brightest, but the quietest. The thought reverses an old expectation. For a long time, the search for intelligence was guided by the idea that intelligence would communicate and that technological maturity would eventually turn outward in recognizable ways. Beacons, message, megastructures, engineered stars, and detectable waste heat all seemed like reasonable consequences of advancement. The dark forest asks whether advancement might instead remove those signs. A young civilization leaks and broadcasts because it does not yet understand the danger, or because it believes the galaxy is benign. An older one has already passed through that optimism. It has seen enough, or reasoned enough, to know that a signal is not just information. It is a vulnerability moving outward at the speed of light. Silence, then, is not backwardness. It may be maturity. The loud are not heard because they do not last. The quiet are not heard because they do. This possibility makes the Fermi Paradox feel darker than simple loneliness. An empty galaxy would be sad, but it would not be hostile. A galaxy filled with concealed civilizations is more difficult to bear, because it means the long-awaited answer may already surround Earth in forms that cannot safely speak. The lack of contact would not be a failure of technology alone. It would be the expected shape of a universe where everyone has learned that the cost of being known is too high. Radio silence would become a kind of shared law, not written or agreed upon, but enforced by the disappearance of those who break it. Over enough time, the visible galaxy would be pruned of carelessness. What remains would look natural from the outside, because natural appearance is the mask under which intelligence survives. The dark forest also changes the meaning of discovery itself. In a hopeful model, finding another civilization is an opening, a first step toward knowledge. In the forest model, discovery is a crisis. The discoverer has learned too much, and the discovered may soon learn that it has been seen. A civilization that finds another must decide whether to remain silent, flee, hide more deeply, observe, warn, or strike. Each option carries risk. Remaining silent allows the other to grow. Warning reveals the warner. Observation takes time and may be detected. Attack may be immoral, unnecessary, or dangerous if the target has hidden strength. There may be no clean choice, only choices that differ in how much uncertainty they leave alive. That is why the theory has such a cold internal consistency. It does not make destruction attractive. It makes every alternative unstable. Even mercy becomes a wager placed on another civilization's future conduct. Beneath the metaphor, then, lies a bleak form of natural selection. Not biological selection among organisms, but strategic selection among civilizations. Behaviors that reveal too much are punished. Behaviors that assume too much are punished. Behaviors that delay against fast-growing risks may be punished. Behaviors that hide, limit exposure, and remove threats early may endure. The result would not necessarily be constant war. It might be something quieter and more unnerving. A galaxy where open conflict is rare because potential conflicts are settled before they become visible, or avoided by remaining unseen. There may be no grand battles, no shining fleets, no dramatic frontier. There may only be brief signals that stop, unusual worlds that go quiet, and long periods in which the stars appear untouched. From the outside, such a galaxy could be mistaken for innocence. Its violence, if it exists, would be sparse, hidden, and efficient. This is why the dark forest stands apart from many other answers to the paradox. It preserves abundance while explaining silence. It allows life to be common, intelligence to be recurring, and technological progress to be powerful, yet still leaves the sky mute. It says the galaxy may be full, not in spite of the silence, but because of it. The quiet is not what must be explained away. The quiet is the mechanism. Every hidden civilization becomes another reason for others to hide. Every vanished signal becomes another lesson. Every unknown listener gives each speaker a reason to lower its voice. A few dangerous listeners may be enough to make caution rational for many. A few vanished civilizations may be enough to teach survivors that the safest place in the cosmos is behind a veil of ordinary starlight. The metaphor closes around the Fermi Paradox with unsettling neatness. The Milky Way can look empty because looking empty is what surviving intelligence learns to do. The absence of voices may not mean the absence of minds. It may mean that minds have discovered a common discipline without ever meeting Do not shine too brightly. Do not speak too freely. And do not assume the darkness is unoccupied. Earth becomes troubling in the dark forest argument because it has never behaved like a civilization that believes it is hidden. For most of its history, the planet was quiet in the technological sense. Lightning spoke in natural radio bursts. The sun washed the upper atmosphere with charged particles. The oceans, forests, storms, and living chemistry altered the air, but they did not send structured signals beyond the solar system. Then, within a thin slice of time, one species began filling near space with artificial emission. Radar swept outward. Television and radio leakage escaped unevenly through the atmosphere. Military systems, planetary radar, spacecraft commands, and scientific transmissions created a growing shell of activity around the Earth. Much of that radiation weakens quickly with distance, and most of it is not a deliberate beacon. Still, the change is real. A world that once blended almost completely into the natural background began to carry technical fingerprints. From the dark forest perspective, the important point is not that humanity has shouted perfectly. It is that humanity has not tried very hard to whisper. This matters because Earth has also sent intentional messages. The Arecibo message, transmitted in the 1970s from the Large Radio Telescope in Puerto Rico, was brief, symbolic, and aimed toward a distant star cluster. It carried basic information about chemistry, human biology, population, and the structure of the solar system. The Voyager records, placed aboard 2 spacecraft, now moving outward through interstellar space, were not radio beacons in the same sense, but they represented the same hopeful instinct, the desire to introduce Earth, to leave a trace, to say that a technological species had appeared around a small yellow star. Other efforts have placed names, sounds, image, mathematical patterns, and cultural fragments into space. Most of these gestures are extremely unlikely to be found soon. Space is too large, targets are too distant, and the physical artifacts are moving slowly compared with light. Yet in symbolic terms, they reveal a great deal about the young civilization that made them. Humanity has often treated the cosmos as a place where being known is desirable. The assumption beneath these acts is not always stated, but it is present. Contact is imagined as a discovery, not a danger. Other intelligences, if they exist, are often pictured as older, wiser, and perhaps generous, because the hope attached to them is shaped by human longing as much as by evidence. A civilization struggling with war, disease, energy, climate, and mortality looks upward and imagines that anyone capable of crossing interstellar distances must have solved the problems that still endanger Earth. This hope gives advanced life a moral direction. Technology is quietly linked with maturity. Age is linked with patience. Knowledge is linked with restraint. The dark forest theory challenges each of those links. It asks whether technological maturity might produce not openness, but concealment. It asks whether age might teach caution more reliably than kindness. It asks whether knowledge, instead of softening survival logic, may clarify it until the safest answer becomes silence. Against that possibility, Earth appears young, not only in technology, but in strategy. Its signals have not filled the galaxy. The earliest strong radio emissions from human activity have traveled only a little more than a century outward, making a sphere whose diameter is still tiny beside the Milky Way. Even that sphere is not a clear, bright announcement in every direction. Much of the leakage fades into noise, and many transmissions would be difficult to recognize unless a listener had strong instruments, patience, and perhaps some reason to look. These facts reduce immediate fear. They do not remove the underlying concern. The bubble expands at the speed of light, touching more systems with every passing year. Powerful directed transmissions, especially radar or deliberate messaging, can stand out more than weak leakage. A civilization only has to be noticed by the wrong listener once. In the dark forest, low probability does not feel reassuring when the consequence is total exposure. Earth's position is therefore ambiguous. It is not a blazing lighthouse visible from every arm of the galaxy, but neither is it a silent stone. It sits in a vulnerable middle state, detectable in principle, increasingly active, and not yet capable of defending itself against anything far older than human technology. This middle state may be the most dangerous phase in the dark forest model. A pre-technological world has no obvious voice. A very advanced civilization may know how to hide its heat, shield its broadcasts, scatter its habitats, and avoid simple targeting. Earth has neither innocence nor mastery. It has begun to speak. Before it has learned whether speech is wise, it has opened the door of its shelter without knowing the landscape outside. What makes this especially difficult is that many of humanity's outward signals were not produced by a single planetary decision. Earth does not have one mind. It has nation, institution, private groups, militaries, observatories, artists, engineers, and dreamers, all acting across different motives and timescales. Some transmit for science. Some transmit for communication with spacecraft. Some transmit as symbolic art. Some argue for active messaging to extraterrestrial intelligence, believing that silence is too fearful and that discovery requires initiative. Others argue that no small group has the right to make Earth more visible on behalf of all life that depends on it. The dark forest argument gives that disagreement sharper consequences. If exposure is harmless, messaging may be a noble extension of curiosity. If exposure is dangerous, messaging is not merely a scientific act. It is a planetary risk taken without planetary consent. The difficulty is that no one can prove which universe Earth inhabits. The same sky supports multiple interpretations. Its silence may indicate emptiness, rarity, distance, disinterest, technological invisibility, or strategic concealment. Policies made under such uncertainty are forced to balance hope against caution, and the balance is unstable because the costs are uneven. A message that reaches no one costs little. A message that reaches a benign listener may open a future of knowledge. A message that reaches a hostile or fearful listener may end the future entirely. The outcomes are so different in scale that ordinary risk language begins to strain. The temptation is to dismiss the darkest outcome because it feels extreme. Yet the dark forest insists that extreme outcomes dominate survival calculations when extinction is among them. This does not mean humanity should imagine every signal as a death sentence. The physical realities of detection are complicated, and Earth is not necessarily easy to find by radio leakage alone. A distant observer might detect atmospheric oxygen, methane imbalance, artificial night lighting, industrial pollutants, or other technosignatures long before receiving a deliberate greeting, depending on its instruments and distance. Earth may already be visible as a living planet through biosignatures, and someday as an industrial one through more subtle traces than radio. Silence, if adopted now, would not erase everything. The planet has an atmosphere out of chemical equilibrium, a reflective surface, orbiting machines, thermal patterns, and a star whose light carries the faint imprint of Earth when the planet passes in front of it from certain lines of sight. A sufficiently capable observer may not need humanity to introduce itself, but deliberate signals still matter because they reduce uncertainty. They can confirm intelligence, reveal mathematics, suggest biology, disclose technological habits, and show intention or lack of caution. They turn an interesting planet into a known participant. In the forest. That is a meaningful shift. The deepest irony is that the same curiosity that makes human science powerful also makes concealment psychologically difficult. The species has learned by looking outward, by naming planets, measuring starlight, sending probes, and refusing to treat ignorance as a permanent boundary. To stop speaking would feel like a retreat from one of the most generous human impulses. The search for life is not only strategic, it is also existential. It asks whether mind has appeared elsewhere, whether biology is a local accident or a recurring cosmic process, whether the long work of evolution on Earth belongs to a larger pattern. The desire to answer those questions is not foolish. It is one of the reasons civilization has instruments pointed at the sky at all. The dark forest does not erase that dignity. It places it under shadow. It suggests that the universe may punish the very openness that makes discovery meaningful. Under that shadow, Earth's signals take on a new emotional texture. They are not only achievements of engineering or gestures of welcome. They are traces of a young civilization revealing itself before it has settled the basic question of whether revelation is safe. The radio waves already sent cannot be recalled. The spacecraft already launched continue along their long, cold paths. The expanding shell of human activity moves outward through nearby space, thinning as it goes, carrying fragments of a century in which Earth first became loud enough to matter. Perhaps nothing hears it. Perhaps something hears and does not care. Perhaps something hears and waits. The dark forest solution remains unproven. But if it is even partly right, then humanity's place in the Fermi Paradox is not passive. Earth is not merely listening to the silence. It has added itself to the question. A small, bright, uncertain world, sending signs of life into a galaxy where the oldest lesson may be not to answer. The dark forest argument is powerful because it is clean. It takes a difficult silence, adds a small number of assumptions, and produces a galaxy that looks very much like the one visible from Earth. But a clean argument is not the same as a confirmed one. In science, an explanation must do more than fit the shape of a mystery. It must also survive comparison with other explanations, account for evidence without stretching it, and avoid smuggling its conclusion into its starting assumptions. This is where the dark forest comes under pressure. Many researchers who take the search for extraterrestrial intelligence seriously do not treat the idea as impossible, but they also do not treat it as the most likely answer. They see it as a useful thought experiment, one that exposes the strategic dangers of contact, while also depending on a chain of assumptions that may be too narrow for a galaxy full of unknown histories. The first objection is that the dark forest may be too universal. It imagines that advanced civilizations, once they understand the risks, converge on concealment and possibly preemption. Yet convergence is not guaranteed, even on Earth, where all known intelligence belongs to one biological species. Cultures and institutions respond to danger in many different ways. Some hide, some broadcast, some negotiate, some miscalculate, some accept risk for prestige. Religion, ideology, commerce, science, or simple curiosity. An extraterrestrial civilization might be even more varied, not less. It might be centralized or fragmented, biological or machine-based, expansionist or stable, cautious or indifferent. It might have no single policy toward the galaxy. It might contain factions that disagree for thousands of years. For the dark forest to explain a nearly universal silence, Either most civilizations must reach the same severe conclusion, or the few that do not must be removed before becoming visible for long. That is possible within the theory, but it is also a large claim resting on no direct example beyond human strategic imagination. A second objection is that the theory may overstate the inevitability of conflict over resources. The universe contains finite matter, but finiteness does not automatically create urgent scarcity. Space is not like a small island where every field is already claimed. Even a single star system holds enormous energy compared with the current needs of a young technological species. A civilization able to gather a significant fraction of its star's output may have room for long periods of development without pressing against a neighbor. It might choose efficiency over expansion, computation over territory, small, stable populations over endless growth, or inner complexity over outward spread. The assumption that civilizations naturally continue expanding may be less a law of intelligence than a reflection of biological life under competitive pressure on Earth. Advanced societies may alter their own drives. They may set limits. They may migrate into forms of existence that require less matter than expected. They may value isolation not because they fear attack, but because they have little need for anyone else. If that is true, the silence may come not from a forest of hunters, but from civilizations that rarely become loud empires in the first place. A third objection concerns detection. The Fermi Paradox feels sharp because the galaxy seems quiet, but humanity has not searched all that deeply, all that long, or across all possible signal types. Radio searches cover only a fraction of the sky, a fraction of frequencies, and a brief period of time. Techno-signature searches are improving, but the range of possible technologies is far wider than the range of signatures currently detectable. A civilization may be obvious only during a short stage, or only from a favorable angle, or only through signals human instruments are not designed to recognize. Large engineering projects may be rarer than imagined, more subtle, or physically unattractive for reasons not yet understood. Waste heat is hard to hide in principle, but it can be spread, reduced, directed, or difficult to distinguish from natural infrared sources at interstellar distances. The absence of confirmed evidence may therefore reflect the limits of observation rather than a deliberate galactic silence. The sky may look natural not because intelligence is hiding perfectly, but because humanity is still at the beginning of learning what artificial might look like. There is also the problem of first principles. The dark forest often begins with survival as the primary goal of civilization, but survival may not be interpreted the same way by every intelligence. Some civilizations may not regard indefinite continuation as the highest value. Some may accept mortality at civilizational scale. Some may prioritize knowledge, transformation, or local harmony over endless preservation. Others may merge with their technologies in ways that make the language of civilization less clear. A distributed machine ecology, a planet-wide mind, or a civilization that slows itself into near stasis may not play the same strategic game as an expanding biological lineage. The dark forest reduces alien variety to a survival calculation because that reduction makes the problem manageable. Critics argue that it may also make the imagined galaxy too human, not because it is too emotional, but because it reflects a particular human tradition of strategic fear. It assumes that rationality under uncertainty leads toward concealment and preemptive violence. Yet rationality might also lead toward signaling restraint, mutual deterrence, defensive transparency, or simply non-interference. None of these alternatives is proven, but neither is the forest. The chain of suspicion itself can be challenged. It is true that intentions are hard to verify across light years. It is also true that uncertainty can produce fear, but uncertainty does not always lead to attack. A civilization might reason that attacking unknown worlds is more dangerous than ignoring them. A target might be far stronger than it appears. A detected signal might be bait. A preemptive strike might reveal the attacker to other watchers. Violence may solve one uncertainty while creating many more. In a galaxy where everyone is hiding, the act of destroying another civilization could be one of the loudest possible signals. Even if the weapon is subtle, the disappearance of a biosphere or the alteration of a star system may attract attention. A cautious civilization might therefore avoid attack unless directly threatened. It might prefer camouflage, mobility, redundancy, and quiet defense over extermination. In that version, the forest may still be dark, but it is not necessarily filled with hunters who shoot at every sound. It may be filled with observers who survive by refusing to interact at all. The strongest scientific pushback may be that the dark forest is difficult to test. A theory that explains silence by saying everyone is hiding can absorb almost any absence of evidence. If no signals are found, concealment fits. If a strange signal appears and vanishes, concealment can still fit. If no megastructures are seen, concealment again fits. This flexibility gives the idea narrative strength, but it weakens it as a scientific explanation unless it produces specific predictions that can be checked. By contrast, other proposed solutions to the Fermi Paradox sometimes point toward more testable questions. If life is rare, studies of exoplanet atmospheres and origins of life chemistry may gradually clarify how rare. If technological civilizations are short-lived, searches for atmospheric pollution, dead technological worlds, or patterns of planetary instability may help. If intelligence is uncommon, biology and evolution on Earth can be examined for difficult transitions. If civilizations become quiet because efficient technology reduces leakage, then the search must shift towards subtler technosignatures. The dark forest can guide caution, but it does not yet provide a clear observational path that separates it from other forms of silence. Still, dismissing it too quickly would also be careless. The value of the dark forest may not lie in proving that the galaxy is hostile. It lies in reminding science that contact is not only a question of detection. It is also a question of exposure, interpretation, consent, and risk. The critics are right that the theory may be too bleak, too uniform, and too dependent on worst-case reasoning. Its defenders are right that uncertainty at existential scale cannot be treated casually. Between these positions sits the more careful conclusion. The dark forest is not established astronomy, but neither is it mere fantasy. It is a disciplined fear built from real limits: the speed of light, incomplete knowledge, technological acceleration, and the impossibility of knowing alien intentions in advance. The silence of the universe does not prove the forest. It also does not rule it out. That is why the idea persists even under criticism. It occupies the uneasy space between scientific humility and strategic dread, where the absence of evidence can still be read in more than one direction. The model bends under pressure, but it does not break completely, because the sky remains quiet enough to leave room for the question it asks: if the dark forest is even partly real. The search for extraterrestrial intelligence changes from a purely scientific effort into a question of planetary conduct. Listening remains comparatively quiet. A radio telescope that receives does not announce itself by the act of receiving. An optical survey that searches for artificial pulses, a spectrograph that studies exoplanet atmospheres, or an infrared instrument that looks for unusual waste heat can gather knowledge without deliberately pushing Earth farther into view. In that sense, Passive search belongs to the older discipline of astronomy. It extends perception while keeping the observer mostly still. Messaging is different. Messaging changes the posture of the planet. It sends chosen information outward, often in a form designed to be noticed. And it does so on behalf of a world that has never agreed on what risk it is willing to accept. Under a hopeful view of the cosmos, this may seem like a generous act, a signal of curiosity offered to a possible neighbor. Under the forest view, it becomes a flare raised above a shelter. The difference between listening and speaking is therefore not only technical, it is ethical. A single transmitter may be built by one institution, one nation, or one private group, but the consequences of being noticed would not belong only to the sender. They would belong to the entire biosphere, including every person, every culture, every future generation, and every non-human form of life carried by Earth. No committee can easily represent that whole inheritance. No present generation can fully consult the future. This does not automatically forbid messaging, but it makes casual messaging difficult to defend. A civilization that risks exposure must at least know that it is risking more than the pride or curiosity of those pressing the button. The dark forest forces a widening of responsibility. It asks whether a technological species has the right to make itself visible before it understands what visibility means. It also changes the meaning of exploration. Sending probes into the solar system is not the same as broadcasting to nearby stars. But the long-term path of exploration points outward. A species that survives will likely build better telescopes, faster spacecraft, larger orbital industries, and more capable machines in the outer system. Each success increases knowledge and reduces local fragility. Yet it may also increase the technical signature of Earth. A civilization that spreads into space becomes harder to lose by accident, but harder to conceal as a single natural planet. Habitats reflect sunlight. Engines release heat. Mining changes surfaces. Communication networks knit distant operations together. Even if emissions are controlled, activity leaves patterns. The forest, if real, does not merely warn against one message sent from one dish. It warns that becoming interplanetary may itself become a form of announcement unless expansion is designed around concealment from the start. That creates a quiet conflict between resilience and invisibility. To stay on Earth forever is dangerous because a single planet can fail. To expand carelessly is dangerous because a wider civilization may shine more clearly. The safest path, in the forest model, is neither isolation nor display, but disciplined outward movement, a way of gaining redundancy without becoming easy to map. Such discipline would require habits that humanity has not yet developed. It would mean treating energy signatures as strategic facts, not just engineering byproducts. It would mean debating whether powerful beacons should exist at all, whether deliberate interstellar messages should require broad consent, and whether the search for technosignatures should be paired with a study of Earth's own detectability. It would mean asking not only what can be transmitted, but what should remain untransmitted. In a darker version, it might mean deliberately reducing leakage, masking certain activities, or avoiding signals that identify Earth's location too precisely. These ideas can sound extreme because they belong to a civilization that thinks of the sky as open, yet many forms of safety on Earth already depend on controlling information. Homes have locks. Nations guard military systems. Laboratories secure dangerous knowledge. Endangered species are sometimes protected by concealing their locations. The dark forest extends that familiar principle to a scale where the protected location is a planet. The analogy is imperfect, but it reveals the central concern. Information can be irreversible. Once a signal leaves Earth, It cannot be recalled. Once coordinates are known, they cannot become unknown to the receiver. Once a civilization has been identified as technological, it cannot return fully to its earlier ambiguity. The ethics of contact would therefore need to consider irreversibility as much as intention. A message sent in optimism may travel for centuries after the culture that sent it has changed its mind. It may arrive when Earth is stronger, weaker, divided, transformed, or gone. It may be read in a context no one on Earth imagined. The sender cannot supervise its interpretation. That lack of control should make every deliberate signal feel heavier. The forest hypothesis also raises a policy problem that science alone cannot settle. Scientists can estimate signal strength, target distance, probability of detection, and the physical difficulty of interstellar attack. They can evaluate what is known about exoplanets, radio propagation, and observational limits. But the decision to expose Earth, if it is a decision at all, belongs to values as well as data. How much risk is acceptable for the chance of contact? Who decides for a planet without a single government? Does the desire to know outweigh the right of future generations to remain less visible? Is silence a prudent temporary measure, or a surrender to fear? These questions do not have easy scientific answers because they are partly political and partly moral. The dark forest does not resolve them. It makes them unavoidable. Even the search itself may require a new humility. Looking for others is not wrong simply because the forest might be real. Knowledge has value, and passive discovery may improve caution rather than undermine it. Detecting another civilization without revealing Earth could teach humanity whether the galaxy is quiet, active, dangerous, or simply strange in ways no theory has expected. It could show whether advanced societies leak heat, whether they cluster around certain stars, whether they alter planets, or whether the search methods are still too narrow. But discovery would create its own burden. If Earth found an unmistakable signal, what should be done with that knowledge? Public announcement might be scientifically proper, yet it could also invite others to transmit replies. Secrecy might reduce immediate risk, yet it would concentrate power in a few institutions and corrode trust. A confirmed detection would not be just an astronomical event. It would become a civilizational test of restraint. The hardest implication is that the safest answer may not be the most emotionally satisfying one. Humanity may have to live with partial knowledge, continued listening, careful debate, and a refusal to turn every discovery into an outbound call. In the forest model, maturity is not measured by how loudly a civilization declares itself. It is measured by whether it can act under uncertainty without confusing desire with evidence. The desire for contact is real. The longing to know whether mind is alone is one of the quiet forces behind astronomy, philosophy, and the search for life. But longing is not a shield. Hope is not a defense system. If the dark forest is possible, then wisdom may require separating the wish to find others from the impulse to be found by them. This does not mean retreating from the universe. It means entering it with a different kind of caution, one that treats silence not as shame, but as a temporary form of shelter. A civilization can listen deeply without shouting. It can study the stars without assuming the stars are safe. It can build a future beyond one planet while recognizing that every expansion changes the information it gives away. Under this view, the most important step is not turning off curiosity. It is governing curiosity before curiosity governs the planet. The dark forest, if true, would not demand ignorance. It would demand restraint strong enough to survive knowledge. That restraint may feel unnatural for a species that has learned by touching, naming, mapping, and calling into the unknown. Yet the universe may not reward the first voice that speaks. It may reward the mind that waits, gathers evidence, reduces exposure, and understands that in a galaxy where intentions cannot be read, safety may depend on remaining a question rather than becoming an answer. The comfort of static comes from its refusal to decide the question. A radio telescope pointed into the dark does not hear a galactic greeting, but it also does not hear a confirmed threat. It gathers hiss from instruments, stars, plasma, distant galaxies, and the leftover glow of the early universe. And within that mixture, the absence of a clear artificial voice can be read in several ways at once. It may be the sound of loneliness, the ordinary noise of a cosmos where life rarely crosses the threshold into technology. It may be the sound of distance, a reminder that intelligence could exist beyond the reach of present instruments or beyond the brief window in which humanity has been listening. It may be the sound of difference, because another civilization might communicate in forms that human systems do not yet recognize as communication. But, under the darkest solution, the same static becomes something more protective. It means no one has spoken loudly enough to be heard, or no one close enough has chosen to answer, or no listener with dangerous intent has yet made its presence known. The silence is not reassuring because it is simple. It is reassuring because it leaves the worst possibility unconfirmed. This is the final unease of the dark forest idea. It does not give humanity knowledge. It gives humanity ambiguity, and then asks whether ambiguity may be safer than clarity. A confirmed signal from another civilization would be one of the greatest scientific discoveries ever made. Yet it would also break the old uncertainty that has sheltered Earth since the beginning of its history. Before such a signal, the galaxy remains an open problem. After it, the galaxy contains at least one other technological actor with a location, a history, and an unknown strategy. The discovery would not automatically mean danger, but it would end the comfort of imagining danger only in theory. The same would be true in reverse if Earth were clearly detected by another mind. A hidden world retains possibilities. A known world becomes a fact inside someone else's calculations. In the forest model, that transition from possibility to fact is the dangerous threshold. It changes nothing in the laws of physics, yet it changes the meaning of every choice that follows. Humanity often treats the silence as a wound to be healed, because the thought of being alone carries its own weight. A dead galaxy would make Earth's living surface feel more precious and more exposed. Every forest, coral reef, city, language, memory, and act of thought would belong to a single fragile branch of consciousness in an otherwise indifferent sky. The loneliness of that picture is real. It gives the search for life its emotional force. To find another mind would seem to enlarge existence, to show that the long labor of chemistry and evolution has not happened only once, and that intelligence is not a solitary accident on a small planet. The dark forest turns that hope almost inside out. It suggests that a living galaxy may not be gentler than a dead one. It may be more dangerous, precisely because it contains minds able to fear, calculate it, hide, and act across time. The choice becomes stark without becoming simple. An empty universe is lonely. A crowded universe that must remain silent is colder in another way. Between those two possibilities, the static continues. It neither comforts nor condemns completely. It holds both interpretations in suspension. What makes the dark forest solution difficult to release is that it fits a certain shape of the evidence while remaining impossible to embrace as fact. The Milky Way does look natural. Its stars do not carry obvious signatures of vast open engineering. Its radio sky has not delivered a stable, confirmed message from another technological species. Its planets, as far as present observation can show, remain mostly worlds of rock, ice, gas, cloud, radiation, and chemistry. These observations do not prove concealment. They may point instead to rarity, distance, short civilizational lifetimes, subtle technology, or observational limits. Yet concealment remains one possible reading because silence is exactly what concealment would produce. That circular quality is part of the theory's danger and its weakness. It can sound too perfect because every absence becomes compatible with it. At the same time, the absence cannot simply be ignored. The sky is quiet, and any mature explanation must account for that quiet without pretending the answer is already known. A calm view of the problem has to preserve both sides. The dark forest is not established science. It is not a discovery made by telescope, probe, or spectrum. It is a model built from strategic reasoning, shaped by uncertainty, and sharpened by the knowledge that extinction is irreversible. Its premises may be too severe. Civilizations may cooperate more easily than the model allows. Resources may not drive conflict on the timescales imagined. Advanced life may become inward, efficient, or indifferent rather than expansionist. The galaxy may be silent because there are few minds to make it otherwise. But the model still matters because it disciplines hope. It reminds every search that contact is not only a story of wonder, it is also a story of exposure. It reminds every message that the listener cannot be chosen. It reminds every young civilization that the difference between courage and carelessness may not be visible until long after the signal has left. For Earth, the most honest position may be neither panic nor innocence. Panic would turn speculation into certainty and fear into policy before the evidence deserves it. Innocence would pretend that curiosity carries no risk simply because risk has not yet answered. The space between those extremes is quieter. It allows listening to continue. It allows the study of exoplanets, atmospheres, biosignatures, technosignatures, and the physical limits of detection. It allows debate over messaging without treating caution as cowardice or hope as foolishness. It accepts that humanity is young in cosmic terms, and that youth often mistakes silence for permission. The task is not to stop looking at the stars. The task is to understand that looking and calling are different acts, and that a civilization responsible for a living planet should know the difference before it turns wonder into a broadcast. In that restraint, the static becomes almost gentle. It is the sound of one more night without an answer, one more interval in which Earth remains unaddressed by anything beyond the solar system. The forests and oceans continue under a sky that offers no verdict. The radio dishes keep listening. The spacecraft already launched keep moving outward, faint and slow, carrying human artifacts into distances where encounters are unlikely but not impossible. The sun continues to pour light across planets, moons, dust, and the thin blue edge of Earth's atmosphere. Nothing in the silence promises safety, but neither does it announce disaster. It leaves room for further care. It leaves room for science to become more precise. It leaves room for humanity to think before speaking more loudly. The darkest version of the Fermi Paradox remains darkest because it does not need the universe to be empty or evil. It only needs the universe to be uncertain, and civilizations to understand that uncertainty badly enough to hide from one another. If that is true, then the silence above Earth is not a blank. It is a shelter made of ignorance, fragile, temporary, and perhaps already thinning. If it is false, then the silence may still be the long pause before discovery, the slow interval through which a young species learns how to search with patience Either way, the static is not meaningless. It is the boundary between what is known and what must not be assumed. It is the sound of a question held open by distance. It is the quiet that allows the planet below to continue. For now, beneath stars that reveal their light but not their intentions, the silence remains, not as an answer, but as a final soft boundary around the question, beyond Earth. The stars continue in their ordinary brightness, each one burning according to the same physical laws, each one carrying worlds that may be barren, living, ancient, hidden, or still unknown. Nothing in their light confirms the darkest possibility. Nothing in their distance removes it. For now, the galaxy gives only enough evidence to keep wonder alive and enough absence to keep caution awake. The dark forest may be a shadow cast by human fear onto a universe that is quieter for simpler reasons. Or it may be one of those rare ideas that feels severe because it has touched something real before proof can reach it. Either way, Earth remains here, small and luminous, held by its atmosphere, warmed by its star, surrounded by instruments that listen more carefully with every generation. The planet does not need to choose between curiosity and fear as if only one can survive. It can keep looking, keep learning, and keep distinguishing between the act of seeing and the act of calling out. Perhaps one day the silence will break, and the first confirmed sign of another mind will arrive gently, without danger, changing the meaning of the sky. Perhaps it will never break, and humanity will have to carry the strange dignity of being alone. Or perhaps the wisest civilizations are those that learn to let the stars speak only in light. Until more is known, the static remains patient. It asks nothing. It reveals nothing. It leaves the night undisturbed above oceans, deserts, forests, cities, and sleeping minds. And in that quiet interval, the question can rest without closing, held open by distance, uncertainty, and the faint hope that silence, whatever it means, is still allowing the world below to continue.